Hey guys, and welcome back to another video looking at plotting with Seaborn. In this session, we're going to take a look at how to plot some distributions using the rather interesting Violinplots. So I'm going to go through really basics first, kind of covering what a distribution is. We'll do a dead simple example using some random data. We're then going to bring in pandas and the data set we used in the previous video, which is 1,000 students and their given math, reading and writing scores. We're going to then use that to then plot some distributions. So make sure you stick around to the end where we can look at kind of creating some really interesting, fancy and quirky plots. So first of all, kind of what is a distribution? So suppose we take some data, suppose we have 1, 1, 1, 1, 1, loads of these ones here. In this case here, we have, 1, 2, 3, 4, 5, 6 of the same number, right? So if you took a distribution here, every single number appears once, and that's absolutely fine. But suppose we're looking at things like student scores. So imagine we had a test which kind of went between, 1 and 50. You would expect kind of most people to get around the average. So suppose the average score was around 25. You would see much more scores kind of appear around the 24, 25, 26. So that's when you get like a bell curve situation happening. What I'm going to do, I'm going to do some randomly generated data first using the random module. So we can import this guy in here. Import random as RA. I want to show you what different distributions look like using some kind of random data that we can control with bias. So to get this started, let's just do sum data is equal to a list of numbers, and let's just say this is 1, 2, 3, 4, 5 like this here. And we're going to randomly generate random combinations of these, and then we'll also do some let's see, some bias. I kind of want to get this the same length to make it better. And the purpose of this, if I do a load of ones here and space these guys out, make sure that underneath each one, there we go, that's neat here. If you use a random module, what you can do, which is quite interesting, and we'll call this graph data here, is we can say, take a random selection of these, and the probability of you choosing each of these numbers corresponds to the number below it here in this one. So what you need to do is do random.choices. You then first pass in your data here, so some data, and then as a parameter, as a keyword parameter, we can say weights is equal to some bias, and we then pass in a value for k, which is simply like how many do you want. So we just said 10 here, and just to kind of show you what this looks like on the screen first, we can get this rolling if I get my parentheses the right way around, so it'll probably help. Okay, there we go. So this is with everything as like 1, 1, 1, 1, 1. So basically saying there's an equal chance of us picking the 1, 2, 3, 4, or 5. And you can see here there's no kind of obvious winner. However, let's suppose we come along and said we'll do a 10 for this guy and a 10 for the 5. So there's now a much greater chance of us picking the 1 or the 5. So if we save and run this, we can see that we now get 1s and 5s, obviously a lot more in our data, which we'd expect. So I want to use this first to show what the different distributions look like. And of course, we'll then bring in pandas, we'll bring in our data set, and we'll do some realistic plots. So all we've got to do is do this. I've got Seaborn already imported. I've got matplotlib already imported. We're going to do sns.violinplot here. And yeah, you can see this takes an awful lot of parameters. So all I'm going to do is do, just simply do my x first. We'll say x is equal to graph data here. And tell you what, let's do our kind of even distribution first. So everyone's got everyone's got an even chance of being selected. So we quickly do the plot here, and then we can simply come along and do, in this case, we'll do plt.savefig. You can do your title, your x label, your y label, but I'll save that for when I actually plot the data set using pandas. And all I've got here, I've got my images folder. So I'll do images here, just make sure it goes in the correct folder. And see, it is currently empty, that's fine. And I'll do violin.png. All you got to do is hit run now. Seaborn generates the graph, matplotlib takes that figure and saves it, and there it is. So we can see here, look, checking out our distribution. So if I take the 2, the 3, and the 4 here, so effectively it's saying the 2s, 3s, and 4s, they're the ones that appear the most in this data set. Look at where the 5 sits, it's slightly less. Look at where the 1 sit, there's slightly less of them as well. Let's go ahead and try something. Let's dramatically change our distribution now. So we'll do 10 corresponding to this 1 position here. So we should see this this kind of figure changed dramatically now to represent the fact that, you know, 1 appears a whole lot more. Yeah, there we go. Check that out. So that's kind of like what you're looking for with distribution. We're basically saying the widest point here represents where the most of that number are. So the 1 here, there's dramatically more 1s appearing in this data set than there is like 5, 6, and so on and so forth. Actually, there's no 6s. Matplotlib just does that. It kind of creates the X a bit further than it should, which is fine. You know, we can really accentuate this. We can say, now do 1,000, and let's do like a 4 for this one. We'll do a 0 here. We'll do a 10 there. So we should see a much different shape now. Run that again. And there we go. Oh goodness, that looks like a kind of funky hourglass sort of thing. So look at where our big kind of peaks are. The 1 and the 4. So if we go back, that would make sense because we've done a 10 under the 1 and a 10 under the 4. And we also did a 4 underneath the 3. So we've said, make it slightly more likely to pick a 3 than you would than picking a 2, and of course a 5 has a 0% chance of being picked, so it's not there. And there you go, that's the absolute basics of doing a violin plot here. Of course, this is all well and good, you know, it's nice doing these simple bits at the start. Where this really comes into power is when you then use things like pandas to plot it. So I'm going to quickly introduce my data set. We'll clear the screen and then we'll do the rest of the video using this student data set. Here it is. We used this in the previous video in scatterplots. So we've got a load of students. This is all dummy data. And what we're interested in is our math, reading and writing score here. So we could show, say, for example, over this entire cohort of students, what's the distribution of these 3 scores? And then maybe we can then break them out into things like gender or if they've done a test preparation course. So let's clear the screen and take a look. So I've got pandas imported already. So the first thing I want to do is go ahead and import my data set. So I'm going to do read CSV here. And let's just copy and paste the path to our CSV file. And then we can strip off this first bit here. And that's because it's in the same directory, so I don't need to bother putting that prefix on. I'm going to quickly hit run, just check that it can read the data set. And it looks like, normally takes a second, yeah, we're okay and we're good to go. So what I want to do now is just kind of show this from the ground up. So one thing that you can do with the violin plot, which is really cool, is you can just say, here's the whole data set, just go and take it. And because if I flick to this for a second, we can see that we've got a range of different data types. However, my math, reading and writing scores, these are all numerical, so Seaborn is going to be perfectly happy to take these and just make a violin plot straight off the bat. I mean, like, check how simple this is. You do sns.violinplot, say data, yeah, that's df. I won't bother for now with the title, x and y labels, we'll do that a bit later. But I can literally just do plt.savefig. So the figure is being made here by Seaborn, and we could then tell matplotlib to say, take this figure and images dash, let's do violin.png. And that should do it. So we hit run this time, and if all's gone to plan, it has. I can open my images folder, and we can see a really simple, I mean, check that out, that's what, a couple of lines? And there we go. So it's inferred from our numerical data that this is what we want to plot. And we can see a couple of things here. First of all, we can see our math, reading and writing, you know, individual violins. And we can see the black box in the middle. That's like our box and whisker plot. So the top and the bottom of the box, these represent our upper and lower quartiles. And then we have the median, which is this, hopefully that's okay to see on this. We have our median appearing in white here. So we can see the median, I think they're pretty close in this, but it looks like the math one is a bit lower than the reading and writing. And in general, I would say that the reading and writing violins, the distribution looks quite similar. Like if you look at the peaks of the distribution on the left and the right here, they look pretty much the same, I would argue, across the reading and writing. The math one though, I mean, that's right down here. So it looks like from this cohort of students that people generally do, you know, pretty much the same reading and writing. It looks like math, though, has a bit more of an even distribution, and, you know, the average looks a little bit lower to me. So that's purely just from passing in the whole data set. What we'll do now is we'll start to actually pass in some stuff for the X and the Y. So I think what I'm going to do, before we do any of the savings, just sort of set up my labeling down here. So I want to do our X label as something. So this bit is basically evoking matplotlib here. So there we go, Y label like this. So imagine this line of hashtags. This is all the Seaborn stuff above, and then this is like the matplotlib invocations down here. So we can do title like this. What we can even do, this might make things quite nice. Let's make these guys into F strings. So if we do this here, and then this guy, see if we can be really fancy, we can do something versus something. You'll see why I'm doing this in just a second. This is just a nice way for me to kind of speed this whole process up. So we can do, let's do xval as something, and then we'll do yval is equal to something here. And then what I want to do is then take our x here, our x in there. Maybe I should have, yeah, there we go, not cut it, but just copied it. Then I can just pass in references to the column names then. So yval, yval. And then here, let's do on our x, let's do reading score. And what I'm now going to do for my y value is do gender here. So this is just a nice way of me kind of, passing in an x and a y value and then copying that straight over to my x label, y label, and titles for our graph. So x is going to become xval. So we are plotting the reading score on our x-axis, and on our y-axis we can go ahead and do the yval. Don't worry about deleting the graph each time, they overwrite, so that's fine. So what we've got this time is, because I've said on the y, go ahead and do gender, because for this data set, it's just got the male and female, so that in this case here, we can see that it's gone ahead and created two separate shapes, and on the x-axis, it's basically showed how each of these distinct groups, basically how their reading score is distributed. So we can see, looking at this pretty close, it looks like the female median is slightly further ahead than the male, and it looks like the male reading score is a bit of a smoother kind of curve here as well. The female median as well, if you look at the peak here, it looks to be just past the male one. So if you were looking at this data set for the first time, this would be a nice way if you wanted to compare, what's the difference between reading score across male and female. Well, you could say it looks like the females tend to do better. They've got a slightly better median, slightly further ahead. It's a bit further forward on the X. And yeah, if you look at where the kind of the peak is, yeah, that's further than the male. I mean, the male one's a bit smoother, to be honest, but yeah, again, I would argue that the bulk of like the mass of the female graph is slightly shifted towards the right-hand side, so it's a more kind of, it's more distributing towards the upper end of these reading scores. We can then shift a y-val to something else. So if we go back and look at our data for a second, we can look at this parental level of education. I'm copying this because I don't want to type that out every time. And I think there's a couple here. So we have some college, a master's degree, associate's degree. So if we were to put this as our y value, it's going to create effectively as many distinct values we have for this level of education. It's going to create that number of violins. So again, we can not worry about deleting it, rerun it, and go and check out our graph here. And it looks like, oh goodness, 1, 2, 3, 4, 5, 6. 6 is quite a lot here. If you actually do plt.show, you can actually kind of extract this out and see it. In fact, I will give that a go. We'll take a look at this not in VS Code. All you got to do is just remove your save fig for a second. And if you do plt.show, just bear in mind what it does lock up VS Code here. So it will, until you've closed the figure, it's going to keep this program running. So if we hit run, there we go, we can see our graph. And this is just with all the default settings. And again, let's just take a look at this. The actual distributions themselves, it's not too, I wouldn't argue there's a huge amount in it. I mean, if you take kind of the obvious ones, master's degree, I mean, of course, I don't know how pious this data set is. But to me, it looks like the master's degree subset that has the furthest median here. And do we have one which is obviously the other way? It's probably this. We've got high school and some high school. It looks like this white bar is the lowest here. And again, I mean, look how simple that was. That was a couple of lines worth of work. And we can easily say, over this entire data set, show me how 1, 2, 3, 4, 5, show me the distribution for 6 distinct groups of people from a given data set. We can then take this one step further. What I'm going to do this time is I'm going to keep X as my reading score, keep my Y val as gender here. So if we just go ahead and quickly hit run, we can see this first produces this graph which we saw earlier. But then what we can then go ahead and do is I can then pass in something under this hue parameter here. And this is going to be, I'll just show this in the CSV file real quick. We can do the parental level of education, or we can pass in lunch as well. So actually, I think we'll do lunch. That gives a slightly cleaner result. So we can see students either have a standard or a free/reduced lunch. So let's see how this affects our data. Let's copy and paste this here, and we'll pass this in under our hue parameter. And let's quickly hit run, and we'll see what our graph looks like now. Now, the purpose of the hue parameter is to basically give us another way to group the data. So if I quickly head back here, on our X, we said reading score, so we can see distributions for reading score versus gender. So that's why we can see our females at the top and our males at the bottom here. By passing in this hue parameter as lunch, it then further splits these into their respective groups. So let's take a look and see what we got. The orange one is our free/reduced. And I would think just by looking at this here, I think it's more obvious, I think for the males, to be honest. If you look at the bulk of this violin section here, so look, this bulky bit and this bulky bit, this to me looks like there's way more mass to this violin below here than there is for the one that has the standard lunch. And it's the same for the females as well. If you look at this free reduced section here, yeah, way more of the graph is this side compared to this side on the right here. And I think that's a really interesting thing that we can do with Seaborn, is we can kind of we can take something we're trying to measure, break it into groups, and then break those into groups again, which is quite nice. And just to point out as well, we can see our medians, so we can see our white lines for these different groups here. We see our interquartile ranges with these little boxes. And yeah, I just think it's a really nice way to do it. I mean, if you were just to use purely matplotlib, I mean, you'd be using a hell of a lot more lines than this. So it's a really nice, simple, powerful way to show some distributions. So to round the video off, I'm going to take a look at 3 additional things we can pass in. There is an awful lot. I'll make sure I'll leave the link to the full list of these in the video description. But 3 of our favourites, however, are as follows. I'm going to do colour first, and just pass in colour is equal to red here. Hit run. And we should see our graph reproduced, and as you guessed it, it just changes the colour of the individual violins here, which is quite nice. Now the next one I want to use is the colour palette for the whole graph. It's advisable to use this one with a hue here, so if we do the hue as being equal to, let's do lunch here, then I'm going to pass in palette as a keyword argument, and let's see, if I go ahead and do pastel, basically what it does, it changes like the overall colour scheme of the plot. So if I look at the graph now, we've got these kind of, I suppose, are pastel-y kind of colours. Yeah, it looks a bit softer on the eyes, doesn't it? And there's a whole range of these which are in the documentation. And this is personally one that I use every now and then, I suppose. It makes the graphs look a little bit nicer. And the last one I want to take a look at is the split one here. So I'm going to quickly rewind this back to a more simple version, just for a second. Hit run and just see what our graph looks like now. So see how around our box and whisker, it's symmetrical on both sides, right? What we can do, if you want to kind of get rid of that to make a graph a bit more streamlined, we can pass in split as equal to true here. And rather than showing your entire plot around this box and whisker in the middle, it'll just give you one side of it, which is quite nice. I think it looks a little bit neater in my opinion. Yeah, like that. I mean, I guess the shape isn't as cool, but the whole point of trying to show a distribution is, so your box and whisker sits at the bottom here, so we can still see the median, and we can still see like the way our scores are distributed amongst the 2 genders here. And again, I think this works well if you're showing quite a lot on one graph. If you don't want to show both sides, you want to keep it a bit cleaner, this is, I guess, a much more of a nicer way of showing it. And there we have it, guys. That is the violin plot. And just to reiterate, the whole point of a violin plot like this is to show how things are distributed. In this case here, I can look at the graph, we're simply saying how are reading scores distributed amongst our 2 genders, and then we can pass in a whole range of things like hue, so we can look at how different groups within those 2 genders also present themselves. Again, I'll make sure I'll link the documentation down below. Cheers for watching, and I'll see you all in the next session.